Hi, my name is Aaron Fields. Today we're going to talk about fire streams and the relationship to fire attack. What we're going to talk about is what we should do in actual fire events, not what we can do in a training environment. The fire we are fighting today compared to the fire of 30 years ago is faster. The heat release rate has increased, as has the total amount of available fuels. Nevertheless, heat still rises, gases expand, they move from high pressure to low pressure, and water still puts fire out.
In truth, today's fires are parallel to where the fire service was prior to dramatic widespread advances of our protective gear. Simply put, the fire has caught up to our gear. With the speed of today's fire events, our choice in stream and attack is critical. Skilled nozzle teams applying water appropriately is still and will always be critical to a successful fire attack. That successful fire attack is based around an understanding of how the fire will behave and what effect our tools and actions will have on the environment, not looking at specific phenomenon in isolation, but the event as a whole. What will our attack do to the fire, the products of combustion, and more importantly, how will it affect the potential victims inside the structure? The bulk of this video will be focused on interior offensive fire attack, as that is one of the highest risk, high probability skills that fire departments engage in.
Our occupation has always been one of not only the whats, but the whys. When we have the whys, we can solve the problems that are going to occur on the fire ground.
There is always an exception to the rule, but if we train to understand why we're doing what we're doing and what will likely occur, we can adjust when faced with something out of the ordinary. The only way we will be able to deal with the what-ifs is by preparing for the bread and butter evolution.
For fire behavior, the analogy that I like is juggling. Heat and the byproducts of combustion are constantly adjusting to find balance. The controls on that balance come from the physical environment, the total space, the availability of air, and the production of heat.
Combustion, the process that creates fire, is a combination of heat, oxygen, and fuel that is self-sustaining. This is known as the fire triangle, or in some manuals it is referred to as a fire tetrahedron. The only leg of the fire triangle, or fire tetrahedron, that the interior offensive nozzle team has control over is the heat leg. Water cools the environment, thus breaking the fire triangle and extinguishing the fire. Water must be delivered in sufficient volume to overcome the heat release rate of the burning material. The laws of physical science dictate that hot gases rise, that gases expand as they heat up, gases move from high pressure to low pressure, and while moving, these gases will take the path of least resistance. During a fire attack, as the byproducts of combustion are combined with water, steam, and air movement from the line itself, the environment will be in constant flux trying to establish a balance. The thermal balance will be degraded to a lesser or greater degree depending on the actions of the hose team.